Hey, Zia. How you doing? Hey, Max. How you guys doing today?
All right.
Really good. I have selection today. You guys haven't had a chance to do much reading at all, or with the end of school, it's been kind of tough. So.
Yeah, I've been pretty busy.
Yeah,
yeah. With graduation this week.
Yeah. We'll finish up today, and then you guys, obviously, there's no time limit. You could always review the videos that we've got here, so they'll be on the website. So if you have questions, what I really want everybody to do is to take their test, take the quizzes, just so I know where everybody's at. If you're going to continue on and get your ground, uh, the, if you're going to take the ground exam, is the practical knowledge test. And then I'll sign you off and then get you guys down there. As far as flying, then just in medical at some point, you have to have the right way for lessons. And then that Sporties course is really good. It doesn't cost you anything. Basically, just go on there. They've got a bunch of really good quizzes that you can take. They're FA questions. They can show you, obviously, give you the answers, and then you can kind of figure out where you're at if you understand the material. And obviously, you can always get questions on it. We've covered all the time. This is a lot, and you guys obviously know that it's not something that some people just pick up right off the bat. Definitely need to have. But you've got most of the stuff on the way. So actually, the flying is the funnest part. This is the hard part. The ground surface, getting all that knowledge, and then it's just a ready to get your private pilot's license, and then who knows where it goes from there. Just a big right here. Hey Donnie, how you doing today? Give yourself plenty of space between each other. So you've got a little room because we're gonna use our sectional charts. These here we're gonna apply all days. Wait a few minutes here. Rich is too.
You got Finn hanging out.
What's that?
Yeah, you got Finn hanging those.
Well, they did, yeah, already, yeah.
Yeah.
I was really upset that they sold it at such a cheap price. It was like $20,000 for it.
It's like they also redoing the inside.
Oh, they are? Wow, nice.
It's nice.
That would have been a nice place to have our SIA offices. So we're looking at maybe over here, really nice big hangar there. All right, Tegan. How you doing? Good. Yeah. Good. All right. Let's dive in. So I think last week we left off on the E6B. Is that correct? That's it. Okay. All right. So so we did the wind side, I think, last time, correct? You guys have any questions on the wind side of the computer? So you want to get your E6B out and follow along with me. So the one thing you're going to learn about the E6B is that it's got a lot of instructions on it. So if you look at the wind side, here, if you look at your wind side, there's a little area on the top here, and it gives you a description of what you have to do. Okay, so that's on the top of the wind side there. If you look on the other side, the calculator side, hey Logan, how you doing?
Good.
You could, if you want to just sit right here. We're going to need you're going to need some space for the sectional charts. So, and you'll need your E6B on here. So let's take a look at the calculator side. So all this is, and you can see this, it's got like a little, they call it a whiz wheel. You can spin it around. All it is a slide wheel. We use this to get to the moon. We use slide wheels like similar to this to actually put people on the moon, which is actually amazing. In World War II, pilots and navigators had something similar to this, and they basically executed all their missions using this, navigating with this right here. So there's a lot you can do with it. A couple things you need to know about it. So on this side of the calculator side, there's a little tick mark right here. Take a look at your E6B. It might look more like something like this, a long triangle, but this right here is the index mark, like a speed indicator right there. You see that mark there? You can see it on your thing there. So that will actually, well, you'll use that a lot. That's called the index mark. I believe in the so, and every E6B might be a little different. Depends on which one you have. So the markings may be a little different. They'll all have the same numbers and little windows and things like that, but the text descriptions may change a little bit. So you see this little mark right here. It's our index right there. If you look down on there, the description on your, where it says, for time and distance, it should have a area there that says for time and distance. You're going to see the index mark, that little triangle corresponds to that right there. And these lines right here, like set miles per hour, knots, whatever, you'll have a line there. That denotes the difference between the outer ring and the inner ring right here. So these are actually labeled. Hey Trey, these are actually labeled A, B, and C rings right here. So the ones you really want to focus on are the outer ring and the inner ring right here. Sometimes referred to as the middle ring, but I'll just refer to it as the inner ring right here. So outer ring here, inner ring is this whole area right here. Okay. So in here they actually give you directions here. Like on yours might be a little different. On some of these, I don't have a diagram of it, but if you look at it, on yours, it may look somewhat, I'm not sure that when people hold there, they can see that. There's a, if you look at it where it says for time and distance, it's got the index mark pointing at speed there. You see that? Does everybody see that? Yep. So, and then below that, you've got, and to the right of it, you've got, well, to the right of speed, it says distance, and then below that, it says minutes, and then hours. So those are that's what you're going to be reading from those rings, okay? So let's actually do a real basic flight. Let's say we're going to fly for 1 hour at 100 knots. So what it says here is to do speed computations. We're going to set our put our speed index, this little mark right here, over our speed. So let's say our speed is 100 knots. So I'm going to go ahead and rotate this index up to where it says 10. You'll notice that there's no 100 on here. So because of the limitations of this, we have to add a 0 to that. Okay. So if it says, 110 or 100 knots, we're actually going to use the 10 marker right there. So your E6B should look, just do this online here. So your E6B should look like what I've got here. See that right there. That index marker should be pointing to 10, which in this case we're saying is 100. Right. So let's say we're traveling for an hour and 10 minutes. Okay. So what we want to do here with our E6B is we want to read the number of hours that it's taking us to get 110 minutes. So let's see. Let's see. Let's see. So we're our distance is, I would say it's 100. Let's just use 120 nautical miles. So what you're going to do on the outer ring, just like it says in the E6B here, the distance is the outer ring. So we're now going to read the distance on here. We set our speed right here for 100 knots. Now we're going to find 120. And again, there is no 120 on here, so we just go to a 120, the area that says 12. That, and then we just multiply it by 10. That's 120 right there. And then what we're going to do is we're going to drop down. We found 120, which is right here. We're going to read down there, and it's saying, what was that right there? 72, something like that. Okay. So let's just say it's 72. So on our little chart down here, or on your thing, if you read the inner ring, the middle ring, it says min. See that on yours, there's a little area that says minute. So that's minutes. So we're now reading minutes. So 120, let's see, 120, so 72 is what we came up with the inner ring. So would it make sense to say that that's 72 minutes as opposed to 720 minutes? Yeah, yeah. You have to, again, use a little bit of common sense when you use the E6B. So 720 is, well, think, okay, so, right, let's use some practical math here. So to go 60 miles in an hour, how far is that? Or how long is that? Let me just say, if I were going 60 miles an hour in 1 hour, how many miles will I? 60, yeah, okay, really simple. If I go for 2 hours, how many miles will I travel? 120. Yeah, okay. So again, use that common sense here. Knots are not that much different than miles per hour. They're long, like a nautical mile an hour is a little bit faster than a regular mile per hour. And a nautical mile is a little bit longer than a regular mile, statute mile. Okay. So with that in mind, if we go, 120. Here we're saying distance is 120 nautical miles here, and we're reading 72 on this inner ring right here. It would make sense, yeah, that we're probably about an hour and 12 minutes, something like that. That would make sense. If you look down here on the C ring, the inner, the far inner ring that is right here, it does back up what we're saying. for about an hour and 12 minutes on there. So that's how the speed calculations work. So again, to do your speed and time calculations, you just basically set your index number to whatever your speed would be. Again, because it's got all the numbers there, but they're just missing the decimal point essentially. So if I was going 700 knots, then I would move my speed index right here to 770, and then I'd add 0 onto that. Then obviously you're moving the speed of sound, so you would read the corresponding times and distances with the additional zeros on there. So again, just a dose of common sense. The nice part about this is normally when you fly, you're always going to be flying the same speed, and you can do calculations just by setting that. You'll know, okay, well, what if I go 2 hours? How far will I get at 80 knots? So let's do this. Let's run that. So you set your speed index to 80. That's our speed. Okay. Okay. And then we want to go 2 hours. So we look for 2 hours on our interval right here. And we read it right here. There's 2 hours. That's the far end. That's the C right there. And then we go straight up right here. This is 120 minutes. 2 hours is 120 minutes. There it is. That's the interval there, the middle right there. And then up here on the outer ring, we read roughly about 160. That's what we should be reading there. So is it 16? Well, should I say, is it 16 nautical miles that we've traveled, or is it 60?
160.
Yeah. Just common sense stuff when you use that. So, all right, good. It's also you guys got that. So for fuel computations, does everybody understand that, by the way? So for fuel computations, what we're going to do is we're going to set our gallons per hour. So let's say we burn 5 gallons per hour. So the speed index is going to go to 5 or 50 here. Again, here's on your E6B is going to have is going to look something like this right there with the instructions there. Yeah, it depends. Every E6B is a little different. Some of them have more documentation, a little easier to understand. The thing is, you want to get comfortable with these, because you are going to get tested using 6B. There are ways to do it by hand, but it's a lot of work. So, all right. So let's say we're traveling. Our aircraft burns 5 gallons per hour, and we're traveling 80 nautical miles. So let's see if I did that right. Well, no, I'm sorry. So you're traveling for an hour and 40 minutes, and you want to see how much fuel you actually burn. So again, our fuel burn is set at 50, which is representing 5 gallons per hour of fuel burn. And let's say we go for an hour and 50 minutes. So what we want to do is, again, go around to where our time is. And you can see right here on the far interval, C right here, at 150, it equates to 110, which is an hour and 50 minutes, right? 60, 50 plus 50 equals 110 minutes. And up here, we read what our fuel burn is. So would it make sense that we burn 90 gallons in an hour and 50 minutes for 9 gallons? Yes. Yeah, think about it. So if you burn only 5 gallons, again, this is where you use common sense. If you're we're burning roughly 5 gallons an hour, and we're under 2 hours, so it's got to be less than 10. Yeah. So you'd be, and again, that's the thing that the FAA is going to watch out for. They're going to throw you questions, and they're going to have that in there. They're going to say, well, it's going to take 110 gallons when really it's only 11 gallons. So you have to be aware of that, or 1.1, they'll have that as an answer in the multiple choice question. So you again have to use a dose of common sense, and then you go from there. So, all right, good. So for density altitude, again, it's got, if you look on your E6B, yeah, there's an area that says for true airspeed and density altitude. And on my E6B, it's right in this quadrant right here. So if, if you're given, air temperature and your pressure altitude, so let's say you calculate your pressure altitude to be 5,000 feet and your outside temperature is minus 10. So what you're going to do here is adjust this. So again, let's see where we go. This is airspeed correction. We're going to set minus 10 over 5 there, the pressure altitude 5 there. And now we can read our density altitude up here. That's what we have there. So again, we're going to calculate our pressure altitude. And then once we've got pressure altitude, we'll set pressure altitude here. And then we'll set our temperature, which is minus 10, right over the pressure altitude. And then we'll read the resulting density altitude right here, which is roughly 3,000 feet, something like that. That, again, use common sense here. So minus 10 degrees Celsius is colder than normal. So what is that going to do, or how the aircraft feels? Is it going to feel like it's at a higher altitude or a lower altitude? What is colder? What's the difference between warm air, the density of warm air, and the density of cold air?
Cold air is denser.
Yes, cold air is more dense. So the plane is going to act like it's lower in the atmosphere. Okay, that's how we, and that makes sense right here, 3,000 feet. That would make sense for something like that. Again, use common sense. Do you guys get this part of it right here? These windows are really small, 6 feet, and it's hard to get something really precise. Trey, you got a question?
No, I'm just thinking.
Does it not make sense here, what I'm showing you here?
I don't know. It's not clicking for me right now.
Okay, so you need to calculate your pressure altitude, which we know how to do. You guys remember calculating pressure altitude. So what you do is you figure out what your pressure altitude is, and then you're going to look for the pressure altitude in this window. See how it says pressure altitude right here in thousands of feet? So we look for 5,000 feet, we're at 5,000 feet. And we take our current temperature, which is minus, let's say, 20 degrees or 10 degrees. And we put that minus 10 degrees across from our pressure altitude. So right here, it's kind of hard to see on the very tip of that. You'll see there's 5 degrees right here, 5,000 feet pressure altitude. And then we go up from there. We line up that minus 10 degree. Now, be careful here because you've got plus 50 degrees Celsius here and minus 50 degrees Celsius. So you want to make sure you use the right, sign there, whether it's positive or negative. And you're going to line that up with the in this case, if I said minus 10 degrees, the temperature, you line it up with that. And then once you have that done, you read your density altitude right off that mark right there. So our density altitude, there's 1,000, 2,000, 3,000. Oh, so yeah, it would be 3,000 feet. That's the altitude, which is obviously lower because, again, it's lower than standard temperature. Okay. Does everyone remember what standard pressure and temperature is? Yep. It's temperature, standard temperature.
15.
15. Yeah. Perfect. Yeah. So those are things that you want to have. Again, you want to know that stuff ahead of time. Because that's going to affect, your common sense calculations on a lot of this stuff. So, okay. For altitude correction, there's a difference between airspeed correction and altitude correction. So if they give you a problem to solve altitude correction, you're going to use this side of it here. And on this side here, let's see. For altitude computations, it says right on your E6B, it'll say something like for altitude computations there. So this is where you would use that. And then for true airspeed and density altitude, you would use the other one. So, and again, every E6B is laid out differently. Just make sure you know what you're solving for there. So, let me see what yours, Trey, maybe you've got a different one there.
Same.
On the screen. It is the same that's on the screen. Okay. So yeah, this one is an older one. It's got the density dial in the center. of the E6B there. See that? Okay. So, all right, that pretty much covers the E6B. There's a lot you can do with this. You can calculate, you do addition, subtraction, division, multiplication, all on this E6B. I don't want to get into that because you'll have a calculator and that you'll probably just use that. But if you want to read into it a little bit more, those booklets that came with your E6Bs, you should have a little bit of it. If not, you can go to the SIA website for your education or the portal there and download the instructions on how to do this with examples. So like I said, get familiar with this before you take the test, because you're going to want to you're going to want to be comfortable with using it and understanding the terms. Again, outer ring, inner ring, and then far inner ring. So these two rings are basically these rings are just the time rings right here. At 9 hours, it's 550 minutes. 8 hours is roughly 500 minutes and things like that. So just get comfortable reading that. So also don't forget that you have a temperature scale, conversion scale. The FA will give you problems to solve with Fahrenheit. We'll say Fahrenheit, but you need to convert it to Celsius because that's what we're going to be using a lot. Any questions at least? All right, so what we're going to do next, let's see. Before we go into navigation, I think what I'm going to do is go into take a look at the VORs. That's and then we'll finish up with navigation, and then the last section we're going to do is paramedical right there. And I think I'm not sure what it is in the book. Yeah, and chapter 16 under navigation. Let's see. I think that's what you got it. And we're skipping just a little bit. We're gonna, yeah, here we go. So on page 16-22 in your books there, we talk about the VOR. So you do need to get comfortable with understanding the concepts of the VOR. So how a VOR works is you have a radio station. So I'm just going to draw Baraboo Airport because there's a VOR station just north of Baraboo. So here's the Baraboo runway. And about 2 miles north of Baraboo, there's a big, looks like an upside down snow cone building. I don't know if you guys ever go by there, you'll see a white tower. It's like looks like a big water tower. It's located, let's say, like right here, and then Reedsburg is over here, let's say. So Reedsburg there. So this is the VOR station, and how VORs work. There's a radio transmitter, and it's a very dedicated transmitter. What it's doing is it's sending out radio waves, 360 degrees of radio waves from here. So they're going in all directions there. There's 360 of those beams getting projected out from the VOR station. And VOR, by the way, stands for very high omnidirectional range, very high frequency omnidirectional range. And they're located throughout the U.S. Nowadays, we use mostly GPS. But the thing is, as a student pilot, you have to know how to use a VOR. They are super simple. So with a VOR station, what you do when you're in the cockpit, you're going to go to your NavCom radio. You're going to have a comm frequency on this side. You'll have a little knob here to set it. And then you're going to have what's called a nav frequency on this side and a little knob to control it. And you'll set the frequency, like Baraboo's is 117.0. So actually turn that knob until you get to the nav frequency of 117. And then you'll have another instrument, which is called an omni bearing selector. And I'll show you this in more detail in a second. It's going to have 2 little indicators up and down. One of them is going to be active, one of them isn't here. It's got dots here on this side here. Okay, and then there's a knob to adjust that too. on there. So what you'll do is you'll tune to 117.0, and you'll hear this frequency. If you turn on the volume for this, you'll actually hear this. It'll be the airport identifier for Barrow in Morse code. It's just dot dot, dash dash. You'll actually hear these tones on there, and that's to verify that you're listening to the right VOR station. Okay, so again, a VOR station it's a fixed radio station. Okay, and they're all across the U.S. They're going to be operational at least until 2030. At that point, they're just going to switch over, and some probably just switch over to GPS. GPS is incredibly precise, whereas VORs are not as precise because they're based on older technology. This is how we used to navigate back in the 50s, 60s, and 70s, 80s, 90s. And then GPS came along and everybody kind of shifted away from it. But you have to understand it. So again, with a radio station, this has 360 radials that project from the station there. So there's a radial for 90 degrees right here. This is the 90-degree radial. And then there's also a radial for 270 degrees, and then everything in between all of those. There's one for 180 and so on and so forth. So let's do 180 here. Let's see, 360. So there's a total of 360, and then up here, this would be 360. That's 360. The thing to remember, and this is a crucial point, do not want to forget this. Radials always emit from a VOR station. They always come from the radio station. So if you want to find out what radial you're on in the plane, even though the plane may be flying, let's say you're flying down here and you're heading south. Let's say right here. Okay. Does it make a difference with the VOR, the way that it works? It doesn't care what direction the plane is in. It's the VOR station is only to tell you where you are in relation to that VOR station. It doesn't know your heading or anything like that. So we want to find out what radial that we're on. So anybody can take a guess what radial we might be on?
17.
Radials always emit from the station. Right here. Yeah. So here's our VOR right here. Here's our plane. So this, if I was right here, I'd be on the 180-degree radial. Okay. And if I was over here, I'd be on the 270-degree radial. So what radial would that put us on there?
100, 200.
Yeah.
200.
Yeah, somewhere in that area. It's going to give us. So we're on that radial from the station. Okay. That's important, from the station. The reason why I say that is because on here, on this Omni bearing selector, it's going to tell you from or to. So usually, well, it depends on the VOR, the Omni bearing selector, but it's either going to have an up arrow or a down arrow, or sometimes it'll have a to flag, or it'll have a from flag on there. Okay, you have to know how to read those. So the to is always up, and the from is always to the bottom. But it may actually say from, or it may say to, and it may say to. One of the, you're going to say one of those, or it could just have one of these little indicators. Up is to the station, from. So why is that important? Why would you want to know who we're from? Well, keep in mind that this plane, again, the VOR station does not know the heading of this plane. Let's say we want to turn our aircraft and fly back to that VOR station. So now we want to go, we want to fly ahead, and we want to actually track inbound to this station. So what you want to do is turn your Omni bearing selector until you get a vector or reciprocal, I call it. So there's radials and there's reciprocals. So in this case, we're on this 190-degree radial right here, 190-degree radial there. But the reciprocal of 190, does anybody know what the reciprocal of 190 is? 10. Yeah, it's 10. It's just 180. Reciprocal on a 360-degree map is always, subtract 180 degrees from it. So in this case, 190 minus 180 is going to equal 10 degrees. So we want to turn our aircraft to 110 degrees to go to the station. So we turn our aircraft around, and now we want to see a 2 flag on our omni bearing selector, and we'll probably be roughly 100, or it will be roughly at 10 degrees to the station. That's the reciprocal. Again, here's a very important point. From indications are always radials. Okay, that's again, radials are always from the station, so from is always a radial. 2 is a reciprocal of that radial. So if we're on the 190 degree radial, the reciprocal of that would be 10 degrees, we determined. And we would want to turn our aircraft around to 10 degrees and follow that radial in to the station there. Okay. This is a very complicated thing for a lot of students. I had real trouble with this when I took my test. I just had such a hard time, making sure I understood it. But the best knowledge I can give you is that radials are always from, and the reciprocals are always to the station. So you can tune this omni bearing selector to whatever you want. This little needle right here is going to indicate which direction you should fly based on, to or from there. And I'll show you that. That shows you how far off you are from the station. So let's actually take a look on a map here so you can kind of see this in action. Right, so here we've got our aircraft, and you can see this orange line right here. That's the heading of the aircraft there. If we want to increase it, so I'm just going to turn this. So let's say we're going west here, or east. I'm sorry. So here's our omni bearing selector. We are receiver right there, and then our radio. We don't see the radio anywhere here, but it would be tuned to viewers. This view our station. So this is roughly 30 nautical miles distance. 30 nautical box right here. So what I want to do is let me just move the aircraft around. So watch what happens here when I move this. So I'm just going to shift that around and see how that little indicator there, that the course, that's called a course deviation indicator, or CDI. That's showing us how far off our course that we are. So let's say we set our omni bearing selector to we want to intercept the 800. We want to go to the station, let's say. So let's do this. We need to actually find out. Let's say we want to just go to the station. So I'm going to turn this knob right here until this shows a 2 indication. There is the 2 indication, and the course deviation indicator here is centered up. Okay, right there. So to get to the station, I actually have to turn my aircraft to a heading of roughly 32 degrees. So let's do that here. So we'll go here, aircraft heading. And notice again, as I change the heading of the aircraft, this does nothing. Again, because the viewer does not care what heading your aircraft is in. It only is concerned with what radial you're on. So in this case, we're on the 216 degree radial, but we're going to the station. There's that little to from flag right there. That's saying to get to this station, if this is lined up to get to the station, we have to fly this heading right here. Now, if you're just out flying around, let's say, and you want to see where you are in relation to a radio station, just this right here. What you can do is just change this. So notice our heading indicators changing as I change that. There we go. All right, so let's say I put our aircraft over. Do this. Okay, so let's say I move my aircraft over here. What would I do to find out what radial I'm on here? So we want to find out using our VOR. First off, the first step is we tune the nav frequency into a radio. So let's say it's variable, that we're northwest of variable right here, and the variable airport's right here. Let's say we just want to find out where we are in relation to this VOR. Okay, what you're going to do is you're going to find, what did I say about from the radials? Are they to the station or from the station? They're always from the station. So what that tells me is if I can adjust this and get a from, see the little pointer right there, that little down arrow, it's pointing to from there. Again, some VOR indicators for bearing selectors don't have those words in there. But in this case, it's got the little down arrow. It may just have a down arrow that's indicating from. Okay. So what you're going to do here is you're going to tune this until you get a to indicator or a from indication. So again, right here, this is where you got to be careful. See how it lines up there? There. That's saying to the station. What, based on this, what is the radio that we're at on the station? And look at this right here, to from. It's saying to. So what would our radio be? Yeah, 320. Yeah, roughly 320. Yeah, down here. You do not read the radial up here where you've got a to indication right here. You read the reciprocal of the radial. And opposite, this is really easy. You don't have to do any math. Just look at the very bottom of this. Usually there's like a little index mark down here to give you an idea of what the reciprocal is. And you can use that as to help all of you define what your reciprocal is. So, okay, so let's do this. Okay, so now we're right on. So it's roughly 140 degrees. 140 degrees would take us to the station. That makes sense right here. This is roughly 140 degrees. If I were to turn the aircraft, it's 140 degrees. Right now it's saying we're at a heading of 269. Let's go ahead and change that. So, oops, too much. So heading of 136 will take us to this station. And again, every time I change the heading on the aircraft, this did not change at all. Again, that's all it's doing is it's telling us where we are in relation, what direction we are in relation to the VOR station. Now, if you had two VORs, you could actually do triangulation by just centering up the needles for two VORs. Most training aircraft have two Omni bearing selectors. So you can actually tune in and tune, they'll have two nav comms. So you'll be able to tune in two VORs. If we had another VOR station down here, we would get the from radio or the radio from that station, and then we get the radio from this station, and then we can kind of triangulate where we're at. Does that kind of make sense? Okay. This simulator, I've got a link to the simulator, so if you want to play around with it a bit more, there's a lot you can do with this. It's a very, the VORs are probably one of the tougher things for pilots to understand, or student pilots to understand. So if you have trouble with it, let me know. If you have access to a simulator, you can definitely tune into this. One of the reasons why VORs are so important is because they give you a radial to follow all the way in. So if you have really strong wind conditions, as long as you keep that needle centered up, you're going to fly directly to your destination. So if I wanted to fly to an airport over here, all I'd have to do, I could fly to the VOR station and then put in the radio for that airport that's over here in my bearing selector right here, and then just track right to that station. So it's a very powerful navigational tool. And this is the way we did it for decades. This is how the airlines did it this way. They did actually have inertial reference systems. That made it a little bit easier for them. But in the old days, it was all by VORs. So does everybody understand everything we're talking about? If you've got questions, again, you guys can email me or give me a call or something like that. Thinking maybe we may have another session some other time later this summer that you guys settled in if you go through your test and the session. All right, so that's VORs. The FAA also has the book also talks about ADFs, which is automatic direction finding. The FAA does not have any test questions on that, and since they're not testing it, I'm not going to get into it. It's really old technology that uses, you could tune a ADF into tune it to a radio station, and then get a directional bearing basically to go to that station. But again, since the FAA is not testing it, and fewer and fewer aircraft are equipped with ADF anymore, we're not going to even talk about it. So some of the problems with VORs. So VORs are they're classified in terminal, low altitude, and high altitude. So terminal radar VOR stations are usually located around a terminal, like a airport terminal. So like they're going to be like Lacrosse has got a VOR. I think they still have one there. That's a terminal VOR, and it's only for like the distance of like with the 30 miles, 25 miles, something like that you're guaranteed to get that VOR signal. So Baraboo's VOR, the Delta Lima Luna VOR, is actually a high altitude VOR, and it's a high capacity. So it's fortunate for us because it's one of the VOR stations that's really the FAA is deemed as the part of what we call a minimum operational network, which is VORs that are essential for the backup of GPS. So if GPS goes out, let's say tomorrow we get a huge solar storm, which we had one actually a couple weeks ago, and I think there were a few minor GPS outages. But if we had a major solar storm and it took out some of the GPS satellites, those VOR stations are impervious to that for the most part. So you could actually still navigate to your destination. So airlines would use those VORs as a backup to GPS. So that's why it's really important for pilots really to understand how VORs work and what they how they handle how they work. So again, terminal, low altitude, high altitude. Baraboo's high altitude, high volume. So Baraboo, I can pick up the Baraboo VOR from in northern Wisconsin. It's that powerful. It's about 100 miles, nautical miles out the receiver. Low altitude, I think that's like 40 or 50 miles, something like that. They're not as far as the high altitude VORs, the high volume. So, all right. Yeah, so a couple other things there as far as, limitations of VOR receiver, because it's transmitting a VHF signal out over the Earth. The Earth, we can't see it from here, but there is a slight, the Earth is a sphere. So if you've got a VOR station like right here, right there, let's say there's a VOR station, and this is our Earth right here. It's only going to transmit in a straight line out here. So if your plane is located right here, it's not going to pick up that VOR station. So it is pretty much line of sight with VOR stations. So the further you are away, the less likely you're going to get that signal. The other thing is, again, it depends on the capacity of the VOR. The other thing you do if you want to get a VOR signal is you can climb up here where you would actually get a signal for it. So that's true of any radio waves. A lot of ham operators, they try to get their radios, their antenna mass up as high as they can, and that's because it gets that signal all away from the Earth's, sphere of the Earth, or whatever. It makes it look better. So, okay, let's see. Any other questions on VORs? Okay. Right. And then deviation indicator. Yeah. So they actually go into the 16 -42. That figure there actually describes using a VOR there, and they've got a really good diagram for understanding it. And HSI, that's on page 16-3. Let's bring that up here. It's a So this is a HSI. They've got the course index. This needle actually moves back and forth. That's your course deviation indicator right there. It tells you how far off your course you are. So if this needle is showing up over here, that means you're to the left of the actual course that you've got turned into the other yards there. It's these dots right here are roughly 2 degrees per dot. So this is showing if this line right here is over on this mark right here, on either a VOR or on this HSI or VOR. Oh, sorry, this is VOR, it's not HSI. If this is over here, that means you're 4 degrees off that course that you've selected here. So in this case, if I were flying to what I'd be looking at right here is I would be flying to the station on 100, or I'm sorry, 360 degree radial. We're on the 180 degree radial, and we're traveling to the reciprocal on the 360 degree radial reciprocal to the station here. So if this line right there was moved to the left over here, that would indicate that our aircraft, there's our imaginary VOR, that's 180 degrees to the station. I'm sorry, 100 degree radial, 360 degrees to so what that would tell me is that my plane is over here someplace, essentially 4 degrees off of that line. So we'd actually be on the 184 degree radial there. Okay, that's what this that line that CD puts or CDI is there. If it slides one side to the other. So let's take a look. This is the HSI. So the difference between the HSI and the regular VOR indicator is that the HSI actually has a heading indicator built into it. So it's a little bit easier to interpret. This has all the same features as the VOR. It's got the to from flag. So the to from flag is going to be right here. This little marker right here is indicates the from flag. If it's got a marker on this side, it would be the course to the station there. So that's the only difference there. But again, basically they overlay a heading indicator right on the bearing selector, which again makes it much easier. These two things right here are for glide slopes. So you can actually tune in a glide slope frequency, which is basically the same frequency as the VOR. And it'll actually give you pitch information. So it can tell you if you're on or if you're pushed into another airplane. You don't have to worry about that because it's for IFR pilots. That would be the next step to understand that glide slope. It's really simple. It'll just tell you if you're high or low with glide slope there. So, heading select. This is just for selecting our heading on there, and this is our we're selecting it here. There, this is a diagram of an ADF. So this is that diagram that I was talking about, 16-32. It actually describes what you see in the cockpit if you have this, radio, the VOR station tuned in, and show you the direction to from, if you're left or right of the course or something like that. And again, everything has to do with the to from indicator right here. So let's see here. Yeah, this is a good diagram for showing magnetic heading versus bearings and stuff like that. Again, this is more for ADF stuff, so we don't really have to worry about that. Nowadays, again, we rely on GPS satellites, and it'll show up picture on your phone, what the what city you're over or something like that. So let's dive into actually planning a flight. So what I've done is I've set up a flight for us to plan, and we'll actually use we're going to open up our charts. So you guys remember how to open up your charts? We're going to open up our Seattle chart to the north side here. So you guys remember how to do that? Okay. So open it up to the north side. And what I want you to do here is look for an airport. It's actually northwest of Seattle. And it's called William R. Fairchild. And the ICAO identifier is 6 Lima Mike. And if you need a little help, so it's probably if you use your flight ruler, turn it to the sectional scale side. It's from the center of Seattle SeaTac Airport. There, it's on. It's like northwest, about 60 to 65, about 63 miles northwest of the Seattle Airport. So find Seattle on the north portion of your the thing, and you can actually, if you get it laid out, you could just, because sometimes it's hard to work with these things. You could just fold your thing, your sectional, so that you just have just the area that we're going to be focusing on right there. Which again, you don't have to do it right now, but I'll tell you that what we're going to do is we're going to actually use only a couple of airports here that are easily visible. So, all right. So again, it's about roughly 63 nautical miles. Again, we use our plotter, and notice on your plotter, there's at the center. Well, it depends on your plotter, but there should be a thing that says WAC scale on one side, and then if you turn it over, it'll say sectional scale. Always make sure that you're using the sectional scale. Because all the test questions are going to be sectional, unless you're using a WAC chart, which most people don't use these days, but they're nice for long flights, planning long flights, and using paper charts. But for the purposes of the FAA test, make sure it's set to you're looking at the sectional scale. So what you're going to do is you're just going to put your scale, put basically 0 on the center of the SeaTac Airport, Tacoma Airport, and then go roughly 63 miles northwest of the field. It's actually, there's 2 big airports there. So, the Seattle Tacoma Airport. You're basically going to go about 63 nautical miles north of the northwest of the airport, and you should see a small town there, Port Angeles. And there's 2 airports there. There's one that's the Port Angeles. The LKO is an AW or NOW. We want to go to the airport that's a little bit to the southwest of that, and that's the William R. Fairchild Airport. So everybody see that on their sectional charts. Got it? Okay. All right. Has everybody found it? So I'll show it to you on the map here. Actually, if you look here, let me just see if I can turn. So here's let's go here. So there's the SeaTac Airport right there. Okay. I'm gonna get those ones off here. So here's SeaTac right here. If I go up and I'll go to the upper left-hand corner here, I'm going to see this little area right here. You see that? Got it? Everybody got it? Okay. All right. So what we're going to do is we're actually going to fly a flight from here to another airport. This would be Airpark, which is W10 for the octagonal identifier. Okay, everybody see that? Okay, what you're going to do is you're going to draw a line with your flight plotter here. You're going to draw a line from the center of that little Fairchild Airport to the Woodby Airport. And use, I've got pencils here too if you guys need them. Everybody's got them here. And make sure it's what you got. Tegan, you made the pencil? Yes. And don't put a lot of pressure on these pencils break easily, but run that line over very several times to make sure you can actually see it. You want the line to go directly, like a straight line from that Fairchild Field to the Woodby Airport. It should be a nice solid line. Don't go past those points. Just keep it within the those 2 points there. Okay. So you should have something on your chart that looks like this. It's got here to here, you should have a pencil line. And make it dark so it's easy to see there. Okay. Already got that? What do you guys have for a distance on there for that?
Oh, 45. No, miles.
45 nautical miles. Anybody else have any? I'm getting for a distance there.
It's like
43 nautical miles. Okay. Did everybody agree with that?
Yeah.
Yeah. Yeah. It's about 43 nautical miles. All right. Good. Excellent. All right. So now we need to, so we've got, let's write that down. So we're going from, let's see, this off here real quick. All right, so we're going from, let's see, the Fairchild. What's the IQ identifier for Fairchild?
27. That's 1.2.
No, the IQ identifier. The
ASOS.
no, the actual identifier. So
Yeah. CLM.
yep, CLM. That's what I'm looking for. So so it's actually KC. That's the Fairchild. Okay, and then our destination is
W.
and actually it might, I don't know if we put in the K on there, but let's use that. K actually is the designated for the U.S. airports. All U.S. airports have a K in front of them. But there are some older airports. I don't exactly understand how that works, but there's some like Charlie 35 doesn't have a K in front of it. When you're working on it. Although on some navigation devices you can type in K Charlie or KC35 and it will actually bring up the Pittsburgh airport. But and that's, I'm not sure what, I should probably know that, but I don't know the reason why they do that. Faribault, for instance, if you look it up on a sectional chart, it'll say K Delta Lima. That's the Faribault airport side K. Okay. All right. So what we need, so we've got to plan this flight. Let's say we're flying Cessna 172. And let's say it cruises at 110 knots. We have full tanks on board, so we got plenty of fuel. Let's see. And what we're going to do here is we're going to roughly calculate how much time it's going to take us to get there based on winds and stuff like that. So let's do it without winds just to see what we got here to kind of get comfortable with using the E6B. So what we're going to do is we'll go back to our E6B. Let's see what we, let's see. So a distance, let's break this down. Distance right here. So it's about 43. Yeah, that's 43 nautical miles. Okay. And then let's see, our plane, we know what our plane travels at 110 knots. So let's go ahead and calculate how long it's going to take us to get there first off. So what we're going to do, we'll go to E6B. Let's to do airspeed calculations. Again, don't be afraid to look at the directions on the E6B on there. So you've got your speed index. What should we set our speed index to? On the outer ring? 11. Yeah, 11. Yeah. So just set that, turn that to 11, which would represent 110 knots. All right, and we've got our distance is what? 43. So where do we set that on our okay, where do we set 43 on our P6B? Or where do we find 43 in our P6B? Inner scale, outer scale, correct. So we look for 43 here on the outer scale, because again, the outer is distance. Okay, so we look for 43. There's 43 right there. And what do we get for the time? 3. Does that make sense? Okay, so our distance is on, we read our distance on the outside. So our distance is roughly 43, we said, right? 43, which is right here. And this, what do we read on the inner ring? That's that V ring there. We read our time on the 8. So across from right here to 43 right there is where my pointer's at. That's 43 right there. Read the time on that middle scale there. Okay, and that's saying be roughly 39 minutes on there. Does that make sense? Okay, so first off, we set our distance on the index, or I'm sorry, our speed. Oh shoot, I had this set. I'm sorry, guys. Yeah, yeah. Okay.
I'm like,
Yeah,
Yeah,
not even close.
Yeah, not even close. Yeah. So yeah, speed index. I'm good. So speed index to 110, and then we want to go to 43. Yeah. 20 spots. So we go to 43 right here, and we're roughly, 23 minutes. Yeah, I would just round this was 118 minutes, and that makes sense, right? We're only going 42 miles. We're traveling at 110 knots, so we in an hour we'll have traveled how many miles? 110. Yeah. So we're much less than 110. So it stands to reason we'd be less than an hour. So in this case, we're about 23 minutes. Again, always remember to do the common sense checks. And obviously, I did not use my own advice there. So yeah. Oh, and again, that's the kind of thing that can get you when you're doing the test. You're rushing through it, and that's what I was doing there. I was rushing through it to get to the next step, and I forgot. I need to set that speed index to what our airspeed or what our airspeed is. So okay, so we know we're around 23 minutes, unless the winds are crazy at altitude. We should be there roughly 20 to 30 minutes. So we now know roughly where. Yeah. So let's say so no winds. Where it's going to take us 23 minutes to get there. And it's travel time. What about fuel? Let's say that plane burns 8 gallons an hour. How much fuel do you use in that time using our E6B? Tell me what to do. You guys tell me what to do, because I don't know what I'm doing. Just pretty obvious here. So we burn 8 gallons an hour. What should I do with this index one? We always start with this.
the rate, 80.
80. Okay, so I'll turn the rate index up to 80 here. Okay. All right. And then what do I do next? So we know our time is 23 minutes. So we actually, where's our time scale? Our time scale is the inner right. So we want to go to 23 minutes, almost out here. 10. Okay, so okay, yeah, again, you're on the right track, but again, use common sense. For an hour, how long does it take us to burn?
30 gallons.
Yeah, so use common sense with this. In 1 hour, how many gallons are you going to burn?
80.
So you can't burn.
It would
Can't burn more.
right, so it would be under 8. So that's one of those things. It just everybody here is doing the same thing. It just you can make those mistakes. You just have to use common sense along the way to get the right things. It's super easy to do. And that's the FAA is planning on it when you take the test. They're going to give you answers that are going to be like, 30 gallons or whatever, something like that. In this case, we know we're less than that, so about over 3.5 gallons or something like that, or not 3.5, but like 3.1 gallons or whatever it could be there. So, so again, it's our fuel burn is roughly a little over 3 gallons for that. Okay, make sense, everybody? Okay, good. Donnie, do you have a question?
No.
Okay. All right. So, so we're going to burn roughly 3 gallons in cruise. So 3 gallons. And again, this is without wind computations. So now let's say it's here. 10 is over there. And there's our course line right here. Let's say the wind, let's give ourselves a tailwind today. Let's say it's going to be out of the southwest, and it's in that direction. So let's say it's the winds are out of 210 at 15 knots at our altitude. Okay. So now we need to go to our wind side and calculate what our ground speed is going to be, which is hopefully going to be less. Now, if you have a tailwind, it again using common sense, if you have a tailwind, is the time to get there going to be higher or lower or less? It's going to be less. Yeah, it's going to be less time. Because you have a tailwind, you've got that wind is pushing you along further, so you'll get there faster. So we said 23 minutes. We should get there after we do our wind calculation. It should do something less than 23 minutes. Okay. So let's verify that. So let's go through the steps here. Let me go in here. Yeah, thank you. All right. So set wind direction under true index. So we set our wind direction. What is our wind direction? 2010. Okay, so we'll set our 2010. Okay, so here's our true index right here. And again, don't be afraid to use this. I'm following this right here. I'm using these instructions right here. So there's the true index, set wind direction under true index, and we set 210. So I'm going to rotate this dial to roughly 210. Okay. That's what you should see on your E6B there. And then mark wind velocity up from center point. So remember that grommet we were talking about, sometimes called grommet, sometimes a center point. That's that little, on some E6Bs, it's the little metal grommet thing. On other E6Bs, it's just a hole in the center of the wind side, the E6B there. Okay, so we want to set our wind speed up from that. And because this slides up and down, this whole thing slides up and down, it doesn't make a difference where you do this at. So, I mean, I can set it from here. If I set my wind direction up from here, it's going to be roughly right there. That's 15 knots. So each one of these is a knot. Regardless, I'm not reading 180, 190, that we're not setting it to that. We're just marking up with 15 knots. So I'm going to click on that. You should have a mark on your, what I do is put an X on your E6B. Up 15 knots from that center point there. Again, I can slide this up and down. See how it doesn't make a difference? It's always 15 knots up from there. See what I'm saying there? So if I can set it at 160, I just have to have that dot 15 knots up from the center point. That there. Does everybody have that on there? Peter? Okay. Very good. And again, I normally use an X on mine just because it's very much more precise. Right? So what's our next step? What does it say to do next? Set true under true index. Okay, so we know what our true course is, right? We have true course. Oh, we haven't. Sorry. We need to find out what our true course is. All right. So with the true course, this is, you're going to get your flight plotter out. This is another important thing, again, to figure out your E6, or to figure out the course there. What you're going to want to do is line up your plotter so that it's resting. And again, make sure you use the sectional sign here. Should really make a difference against either way. But make sure that your plotter is right on that line there, on your course line. See that? That's what you should see there. There, everybody have that? Just lay it right on top of the course line. Yeah. Okay. And I might come around just to make sure everybody's set right. What you're going to do here in a second is you're going to slide this plotter so that this also has a grommet, a little center hole in that, you see that right there? This little center hole. What you want to do is slide that plotter around until you get to a line of longitude there. Okay. All right. Making sure to keep your plotter on that line. So this here. All right, so what is okay, and actually what you're going to do is you're going to read the direction, the true course on the top of this scale off the line of longitude there. So let me show you. I'm going to do this for you individually here. So again, for the people at home, let's see, again, you're going to set your plotter on your line and then line up the center hole with a line of longitude. So this is what it should look like. I don't know if you guys can see that at home there, but there's your little center line that's on a line of longitude. This line right here is resting on our course line from this airport to the airport we're going to. And we're going to read the true course up here off of the line of longitude there. In this case, it should be roughly, you should be reading roughly 98 degrees on there. So let me show you where I'm going to do it. Each individual, this is one of those things that's really hard to do on the finger. So perfect, yeah. So so to go from this point here to this point, our direction true course is going to be right off that, which is yeah, perfect. Okay. Yeah, that's all right. Yeah, it's roughly around there, so yeah. So you can see that. So again, that should be my one. Okay, actually, what you want to do here, let me show you how down here. So what you want to do is first off find our course lines from there. Put your plotter right on that course line. And the second step is you're going to move the center dot to a. Okay, so now you're on that. Make sure you make sure you stay on that dot should be right over. Same thing. Then off of that line. We're going this way, so it makes sense. It can either be 100 or 100, or it can be to this direction. Yeah, it's 90. Yeah, again, the mistake that some people make is that they don't line that center dot up with the that line of longitude. That'll throw your calculations off. So you want to do that. So let's switch back.
I got it.
You got it? Okay. Yep. Okay, perfect. Okay. Okay. And Tegan, you good? Yeah. Okay. All right. So again, 2 steps there. Set the plotter on the course line that you've drawn, and then while it's resting on that line, slide that center hole over to a line of longitude. You could do the same thing with a line of latitude as well if you've got a flight that's more vertical. In this case, we're flying east or from west to east. So we would, it would make sense to use a line of longitude. But if you're flying like, let's say we're flying like this, we're doing this course right here where there is no line of longitude there. On there, we would actually use a line of latitude. And again, same thing there. Put that center dot over a line of latitude, and then you'll read that on the interscale here. So it's really easy to figure out your true course there. This is just the true course. So what do we say our true course was, Don?
98.
Okay, so true course is 8 degrees true. Okay, that's important. That true course. That's we'll call it just TC. 98 degrees. All right, so now let's go back to our E6B. And okay, so let's back up here a second. We've set our wind direction under the true index, which is 210. We've set our wind mark up from the center point, which is 15 knots. From here to here should be 15, should be indicating for 15 knots. Okay. And then the next step is set your true course under the true index. What's our true course again?
98.
All right, so now we're going to switch this over. We're going to put that in 98 to okay. All right. So set true course, make sure we've done that. Slide the wind velocity mark. That's that little X that we put on the 6B there. Slide the wind velocity mark to the true airspeed. Okay, so what we want to do now is slide this whole step until we get to our true airspeed. What's our true airspeed?
1.5.
Well, so the plane we said is 110 knots, right? So that's our true airspeed. We set that wind velocity mark to 110. Okay. Again, we're going to use some common sense here, just the back of the calculation. So we've just done step 4, set wind velocity mark to the true airspeed. Right. Ground speed reads under center. So that's under that grommet there, that center. Our ground speed is actually about 100. Well, you guys tell me what you're getting.
107. 107. 18.
Okay. Any other ones? You said 100.
70.
Are you getting max for yours?
Yeah.
50. Okay. Any other ones? It could be roughly between 100, 117 and 118. Let's go ahead and let's back up here, just because this is an important concept. Let's make sure we go through this step at a time. So what we're going to do, set our wind direction under the true index. So our wind direction is what? We're dealing with so many different numbers. Our wind direction is 210. So we're going to turn, let's all do this together, 210 degrees under the true index. Okay. All right. Mark wind velocity out from the center point. So again, we just have to mark 15 knots of increments up from that center point. If you want to, you can drag this all the way down to the bottom and calculate it. It's a lot of work. We just need to indicate 15 knots up from here. So 180, that's 15. I put a mark here. That red mark is our direction. So make sure you've got that calculation right. So this is 10 knots right here. This is 5 knots, 15 knots. Okay. All right. And then slide or set a true course under true index. So we've set our wind velocity mark. So our true course we said was 98.
98.
98, yes, yeah. Yeah, again, because you're dealing with so many numbers, it's easy to get a little turned around here. So again, I almost made a mistake there. I actually almost learned at 88 there. So it should be right here. This is what you should be reading in your for this step 3. Slide the wind velocity mark. That's the mark that we made. To the true airspeed. Our true airspeed was determined that 172 is 110 knots. So I'm going to slide this until we get that red dot. In my case, yours is X. Get that down to the line that says 110. I'll get something different here. Did something change? But it's again,
The first time we accidentally put the true course under 890 at 88.
Oh, I did.
Yeah.
Oh, okay.
I did the same thing also.
Oh,
That's why I was getting close to that.
yes, that makes total sense. All right. So that's why you were getting, yeah. So again, use common sense. These are the types of things that can happen. So, and I've got gobs of experience working with these things and I still make mistakes on them. So, again, just check your calculations there. I should have read up here on there. So, all right, so we've got that set. We read our true, or actually ground speed under the grommet, which is 115. So let's write that down. So our ground speed is going to be 115 knots. Right. 15 knots, that right there. And then now the next thing we have to do, which let's see. Wind correction angle, that's the next thing we really have here. Wind correction angle reads between the center line and the wind velocity. So let's take a look at that. So they're talking about these vertical lines here. See, this right here is the center line. This right here is plus 5 degrees. This is going to be minus 5 degrees over here. So show it on here. On your on some E6Bs, they actually have plus and minus. Plus is going to be on this side of the that center line. Negative is going to be on this side. Okay. So what we're going to read here, does anyone want to take a guess of what this might be? Maybe what's that? So this is the wind correction angle. What we've take a guess. What was it? Degrees. So what we're actually reading in this case is the bit from here to here, the number of degrees from the center line right here to right here. So, and there's our degrees right here. They actually show it. There's 5. This line right here is the 5-degree line. This right here is the 10-degree line. And there's the 15-degree line. So this would probably be probably roughly about 7 degrees or plus 7 degrees there. 7 degrees, everybody got that? And again, read it from the center line and follow the arc over. You're going to follow those little increments there. You'll get to roughly 7 degrees. So wind correction angle is plus. Say plus 7. Yeah, and it's again, it's going to vary a little bit based on how precisely you put that on there. And maybe I didn't put mine precisely on here. You're getting close to it. That's the thing. It's not the other way around. And when you think about it, okay, so we're heading to the we've got winds, and we think about this problem here. We're flying our plane from here to here, right? So what should we turn the aircraft to counteract the winds there? Should we turn our aircraft to the north, which would be less, right? That would make sense, right? You want to turn it more. You want to counteract these winds. If it's like a current that's flowing up from this direction right here, so we obviously want the plane to point a little bit in that direction right there. So as we go, it's going to track this way, but our heading going over there is going to be kind of down there like that. Okay, so we're close. We're getting close now. Here's the problem now. We have to now deal with getting our true numbers to numbers that we can read in the cockpit. Okay, so what do we have in the cockpit that can tell us outside of GPS and stuff like that? And let's say you don't have any radios, you're just flying directly to this place. We can get there very precisely. But what would we use inside the cockpit to help us out? What else is there to help us to get to that location? What other instrument? It's a really basic instrument. What's that? Let's say we don't have that. Let's just say we don't have that. What's that? Well, that tells us if we're banking back and forth. What's that? No. What other instrument do we have for navigation? Compass. Yeah, compass. It's a super simple instrument. This is the way we've done it for, decades. We've used compasses, and you can still. I used to fly with a guy ages ago that said you should be able to precisely calculate your destination within minutes, even on a long flight. If you use, get all the information available, so you get the winds, the limitations of the aircraft and all the numbers and stuff like that. He said within minutes, and he was right. I actually flew with him. I used to plan out his flight. I'm glad I did fly with him because I learned a lot about not using all the navigation aids, GPS and things like that. And he was within I think it was a minute 50 seconds. I know. But
On like a long flight.
It was like a hour and 20-minute flight, and he was within about a minute 50 seconds or something like that.
He calculated user error.
Probably just very variances. There could have been variances, maybe winds and stuff like that. But he went ahead, he planned all the flights. So you can be really precise with this. With dead reckoning, your pilotation dead reckoning, you can just use the numbers you get off here as long as you get the proper, we need to know the winds at altitudes and stuff, flying at the aircraft and things like that. So, all right. So in any case, it really does work. So now we've got to finish up. We've got to take what we know, which is the true course and stuff like that. We now need to convert that into what we're going to be reading off the compass. Okay, and that's where we go down to this step right here. Okay, so this is where we want to know. We want to figure out, how to get our compass heading. That CH stands for compass heading, MH stands for magnetic heading, and C stands for magnetic course. To go from true course, which is we said was 98 degrees, right? We need to compensate for the Earth's, fluctuating lines, which is variance. Okay. So what we're going to do here is we're going to take our true course, and we need to go back to our map here. We need to look for those variance lines. Do you remember what those look like? Those lines of variance, sectional.
They were
They're right.
They were the purple dotted lines.
The dash lines right here. So if you look on your sectional, you should see a line similar to this. Do you see this? There's their airport, and it's close to where we're at. It's a dashed magenta line, and it says what right there?
16 degrees east.
16 degrees east. You need to remember that, okay? So let's take a look here. There, east 60. So we subtract east variance. So we take our true course. We subtract that 16 degrees, and what do we get? So 98 degrees, we subtract 16 degrees east, right? We get 82 degrees. Magnetic course. Okay, so this is our true course right here. That's true course right there. So we need to convert it to a magnetic course, and we get 83 or 82 degrees for a magnetic course. That's what this is. Again, this is everything is spelled out for you right here. You actually do these steps in this order. True course to magnetic course is true course, which is 98. We subtract the east variance because that's the closest line that we have. So that's the closest line to our route here. So we subtract 60 degrees east. If this said 60 degrees west, we would actually add it. See how it says plus for west there? Now there's a saying you can use if you don't have access to this formula. Everybody on all these E6Bs, you'll see the formulas right on the thing, and it'll say it right there. But east is least, west is best, is the memory mnemonic you can use. But again, you have it right on your E6B, so if you take that to the test, you'll be fine. Okay, so we got our magnetic course, which is 82 degrees. Now we need to solve for the wind correction. So we need to get our magnetic course over to our magnetic heading of the aircraft. So in this case, what we're going to do, we've got magnetic force, which is what? Magnetic force.
82.
82, okay. And we've got our wind correction angle. Do you remember what was the wind correction? 7 degrees. So what do? Do we add it or subtract? Yeah, we add it. Go here. And you can see right here, if it's left of the center line, it's negative, like there. You see that there? It says L on the dash L. So if our dot is on this side, it's going to be minus. And if our dot is on the right side, which it is, we're going to add that total number of degrees, which is like 7 degrees there. So we add that in there. And we get what?
89.
89. Yep. Okay. 89. So it's mind-numbing sometimes when you go through this. Just imagine planning a huge flight, and actually, it's when you take your practical test, they're going to want you to do this. And maybe they won't give you a long flight. They'll just say, all right, here's a 16 nautical mile flight. I want you to plan it out, and they're going to expect you to do this. And you want to get comfortable with this. It's one of those things you just have to keep working on there. Let's see here. So what was I at here? Okay, so that's our magnetic heading. Is there anything else that we need to be aware of? We have to compensate for that compass. Do you remember?
You should follow that flight.
Yes, yeah, compass deviation. Remember in the card we were talking about in the plane? There's a compass deviation card. Let me just see if I can bring it up here. Let's see. Yeah, here we go. We'll just use this one. It's going to be, this compass deviation card is going to be posted inside the aircraft. All right, so we'll just use this. So for magnetic heading of east, we read this over here, steer 86 degrees. So east is 90 degrees. So that's a pretty steep change in there. So we're actually, if we're at, what would we say, 89 degrees?
We said 89.
89 for our magnetic heading. So yeah, we're roughly going to steer in this particular aircraft. We're going to steer for 86. So it's going to be around that area. Now, when you take the test, the values should be large enough. There should be a large enough difference between the values that you can easily determine. It'd be a nightmare if they kept the answers really close together, because I don't think anyone would get it right the first time. So. But again, this is what we're going to see here. So in this case, east is 90 degrees, about 4 degrees less, maybe on our track there. So we said we're roughly at 89 degrees. So I would say, I'd round it up, and I'd say we'd be about roughly about 85, 86 degrees. We'll just say 86 degrees here for our compass heading, CH. Again, headings are always the heading of the aircraft that you're flying in. Okay, whereas a course line is going to be, the actual course that you're flying there. Okay. It's a lot to take in, huh? Yeah. It's what I would do. I definitely, work with these things, practice a couple problems on your own. In the books there, I think they go through some of the things there. There's definitely samples online that'll go through it, and are going to help you out there with this. So. Let's see. Yeah, and then basically that's what you're going to do when you go through your flight plan filing and stuff like that. You're going to walk through those steps there. So, any questions? Yeah. Okay. Let's finish up. The rest of it, actually, we're going to go right into aeronautical or aeromedical factors here. So let's do that. This is easy. This we'll go through it. And by the way, the FAA typically uses the Seattle textbook for examples. But like I said before, there's a PDF, this Airman Knowledge Testing Supplement. You can download this online. This is what you're going to see when you take the FAA test. You're going to be using this right here. So they've got, I mean, it's not like direct answers, but basically all the information that you need to answer a lot of the questions is right in this book right here. So if you download that PDF from the FAA or go to the SIA website and download it, you'll have the current version of it. So, and it's really pays to get familiar with it. Just page through it. It's really boring, but the more you know about it, the easier it's going to be for you to answer questions on it. So let's talk about aeromedical factors. A lot of this stuff you guys could just read. I'm just going to explain a couple things here. Let's see. Yeah, time of useful consciousness. So obviously, when we go beyond certain altitudes, like we go above 12,500, any time you what's that? Yeah, you get hypoxic. Yeah. And did we talk about this earlier?
Yeah, we did a tiny bit.
A little bit.
Okay, yeah. So I won't go into a lot of details here. So semicircular canals. This has to do with how how it detects motion in our brain. So there's one on either side, obviously, of our eardrums here, or ears. These little hairs here, they shift back and forth. There's like fluid in this semicircular canal right here. And what happens is that fluid shifts. That kind of tells us, it helps us keep our balance. The problem that happens in aviation, if you, let's say you can't see the outside world and you go into a long turn, let's say I just go into a 360 degree, I'll do several 360 degree turns, okay? What happens is normally when you start the turn, that you see how the hairs like shift from one side to the other here. This turn starts like this, but after it stabilizes, you're in a constant rate, it reverts back to this. So that's telling you, this right here is telling you you're straight and level. This also is telling you that you're straight and level. And so obviously you're not. Now we've all heard of cases. I think the biggest one was the Kennedy JFK Jr.'s accident, where he crashed. I don't know, this is way before your time, but I think it was the 90s. He crashed, and it was because he lost spatial orientation. He got spatially disoriented. He was taken off at night over the water, and that can be really difficult if you're not IFR training for it. And he basically went into what's called a graveyard spiral. So he did a turn like this and was turning, and then probably just lost his ability to sense whether he was right side up or whatever. He thought he was flying like this when the plane was actually like this. He pulled back on the control yoke to climb because he was thinking he was climbing. Well, all he did was make the turn tighter. The tighter you make the turn, the more drag you're producing, right? And
Less lift.
Yeah, less lift. You're gonna basically come down, and that's what happened. So that was the most famous one, but there's other ones. So again, that's what happens with the semicircular canals in a turn. So you need to be aware of that. Yeah, this is a description of it right here, graveyard spiral. So what's the level of that? Oh yeah, rubber illusions. We should talk about this. So we've gone over this, haven't we? In various parts. Did we go over the different types of what the airport should look like? Well, maybe not.
Yeah.
Yeah,
We spent like almost half the class doing that.
yeah.
Yes, yeah, it was quite a bit of time there. So yeah, the thing about the runway slope illusions, if an airport is pointed down like this, let's say this is a runway right here, you're coming to land, it's pretty easy right here to come to approach. When the airport's down like this, the tendency is for the pilot to approach too high or too low. In this case, they describe it here. Yeah, the runway width illusion here. Runway slope, a downsloping runway can create the illusion that the aircraft is lower than it actually is, leading to a higher approach. So the pilot may think they have to, if the airport is sloping down like this, for instance, the runway's like this, the pilot may think they have to fly a higher approach. It appears that way. So when they're Like then a upsloping runway where it's like this, where you're coming into land like this, the pilot may actually have a tendency to fly over the approach because they slope. So these are some of the types of illusions that you're going to encounter in your so yeah, alcohol and aviation, just simple. Don't do it. Yeah, it's compounded because you are at altitude. So the general rule of thumb is 8 hours bound to throttle. So if you have alcohol, wait at least 8 hours. I'd recommend wait at least 12 hours, especially if you look for the airlines because they have no tolerance. You lose your ticket just like that. You have to find someplace else to work. So again, and they go through all these. You don't have to know all these numbers here, but this just tells you a little bit about what expect there. Other types of drugs, antihistamines, they can make you drowsy and things like that. Think about if you have a cold, and let's say your nose gets plugged up. When you go up into the air, what would a balloon do if you took it from this altitude here and raised it up to 5,000 feet? Would it shrink in size or expand in size?
It would expand.
It expand. That's what happens to your sinuses when you've got a blocked sinus. They expand, and it can be excruciating. I've talked to fighter pilots that have had that happen before, and they said it was unbelievable pain on there. So obviously, if you've got a cold, you could take it up to 1,000 feet, see how you feel. Even that could be painful. So if you've got some sort of sinus blockage, that might be a problem. You need to be aware of. So, and you can obviously take drugs for that, but certain drugs are going to make you drowsy and make you make more decisions and things like that. So you want to be aware of that. So this is just a list on there. And again, you're not going to get tested on this, but you should be aware of those things. That's not there. So scuba diving and aviation. So does anybody scuba dive here? Okay, yeah.
I did snorkeling. I did quite a bit of snorkeling in Mexico.
Yeah. So with scuba diving, what happens is when you dive down to let's say 50 feet or so, something like that, the nitrogen is actually basically, I think I'm getting this right, it actually gets pressed into your bloodstream. Okay. So when you come up from a long dive, you have to decompress. Okay, and what that is doing there is it's allowing the nitrogen to kind of exit your body as you come up to the surface. If you didn't do that, literally it would be like your blood opening up a soda can, shaking it up, and opening it up. That's your blood's doing. If you just go right to the top, it's not physical. You get to the top, but that's what essentially happens is those nitrogen bubbles expand inside your bloodstream, and they potentially create clots or whatever. There's all kinds of things that can go on. So they have you decompress. So the same thing is true if let's say the Earth was just an atmosphere of all water. It wouldn't make a difference. You'd still have to decompress when you're going up to higher altitudes because air is not as dense as water. It doesn't have as much of an effect. But we don't feel like we don't get nitrogen, as we go at altitude. Yeah.
Is that like a fish get all like your eyes pop on something and they're like organs not really off whenever they pull up from deep depths?
Oh, that could be. I've never noticed that. But yeah.
I never thought about that. That's probably true though.
Yeah. Yeah.
Especially some of those deep sea ones.
Yeah. Yeah, that would make sense.
Like eyes will like pop out a bit in there.
Yeah. It's probably like air that's trapped in there too. They may have some small amount of air in there, but if you take them up, it is gonna expand. Those bubbles expand because it's less pressure. When we get to the surface where we've got air now, you still have to worry about it. It's not as bad. So again, that's called the bends, and again, you have to decompress. So what they say there, I think there's a suggestion there. I think it's like 24 hours. After you've done a dive of so many feet or something like that. One of the bends, which is it's not flying for a specific time, so I don't even say it here. And it probably says it in the book someplace. I think it's like 24 hours, something like that. If you're flying there, so. Okay, so this is another area that we're going to get into. This is a very important, and you will see this on the test. So this is the parts of the eye. So one of the things that are there are these things that let me just draw this out here. Um, so here is our eyeball right here. So here's our cornea right here. Say that's our pupil right there. Okay, and in the back of our eyeball here, we've got the cones. Sorry. We've got these rods and cones. So the rods, I believe, are here. Two rods, and then these are the cones here. I think I've got the right guys. Let me just check out that. This one. Yeah, it's yeah, I think this is the, oh gosh. Just take a look here. Here we go. Okay, so they didn't really talk about that. Okay, yeah, it's right there. Okay. So essentially, though, this you've got an area in the back of your eye right here that sees color. So when light comes in here, it perceives color. The problem is at night, if there's no light, as it is at night, these don't work. We don't see color at night. Whether our mind interprets color, but it's really, if you look out into a dark field, you might be able to see shadows and stuff like that, but you're only going to be able to see it in black and white. So because of the color receptors here don't work at night, we want to rely on these down here. So I think the cones are here actually. I think this is cones right here. And these are the rods on the end there. So these surround this area right here. But because of that, what you want to do at night, a practical way of doing this, is let's say you're out flying and you see what looks like a light moving across the sky. You think it might be a plane. So instead of looking directly at it, you're using the center. When you look directly at it, you're using the center of your eye, which is the color portion of your eye. You're going to look maybe 10 degrees off it. If you just hold your hand up like this and just look maybe just to the right or the left of it, now you're going to be using the rods, and you'll actually be able to see the light much better. The rods will be working, to distinguish it. You could try it at tonight when you go out. If you see a distant, like a star or something like that, instead of look at it for a second and get an idea of how bright it is, and then just look a little ways off of it. It doesn't have to be much, maybe the width of your thumb or something like that, and then try looking various distances away from it. But you'll actually notice that it's much lighter when you don't look directly at it. So that's for night vision. That's one of the things that we use to avoid traffic. Look a little ways away from the object. If and again, that's at night. And that's because, again, the cones that detect color are not seeing it, whereas rods are going to be able to pick that up a lot easier. So you always look a little off there. So the other thing about night vision is it takes a while for your eyes to adjust to night. So if you go out to pre-flight your aircraft, oftentimes you'll see pilots with red lights. That's because they want to protect their night vision. It takes about 30 minutes for your eyes to adjust to, in darkness. Okay. The minute you somebody shines a light in your face, a white light or something like that, it's gone and it resets. And now you have to wait another 30 minutes to get that night vision back. And you'll notice we could try it tonight when you guys, before you go to bed, just go outside after you've been inside of a white room, take a look at the sky, wait 15 to 30 minutes. And when you look at the sky again, you're going to see a lot more stars. And that's just how night vision works. So you want to wait roughly about 30 minutes and you want to protect your night vision. You don't want to have a lot of, as you're pre-flighting the aircraft, you don't want to have a lot of light staring you in the face. Very dim flashlight if you're going to have one at all, cover it up. You just don't want any light flashing, or any lights, looking in your, because it's going to blind you there. So, so that's probably the biggest thing there. So hypoxia, I think we've talked about that. There's several different types of hypoxia. This is on 7-2, 7-3. So there's the generic hypoxia is basically what it's saying is that you're not getting enough oxygen in your blood. But there's several different types of hypoxia. You don't have to know the different types. You just need to know that hypoxia means that you're not getting enough oxygen. Hypoxia is very dangerous because here's what can happen with a pilot. Let's say you're climbing out. Most pilots are affected by altitude, probably between 10,000 and definitely 15,000. What happens is you can have a sense of euphoria, and so you feel that everything's fine, and before you know it, you've passed out. So with hypoxia, obviously, if you're going to be flying above 10,000, you should have oxygen available if you need it. For oxygen. No, you have to use everybody in the so there's several different regulations. You're talking about regulations now. So when it comes to required oxygen, you know what it is. So you have to, for the required flight crew. There's several different ones. One of the rules is any time beyond 30 minutes above 12,000 feet.
Yeah, I thought it was 12,000.
Yeah, it's 12,500. After 30 minutes, you have to be on oxygen. After 30 minutes, so I could fly up to 12,500 and stay there for 29 minutes and get down, and I'd be all right. But that's the law. That's legal. Would I do it? No, I'd probably be on oxygen at 10,000 feet, the safe side. There's several things that oxygen does for you, and actually at night it improves your vision. If you can get medical oxygen from somebody and try it on, I'm not saying you should do this, but at night, if you could get some sort of oxygen, go outside, let your eyes adjust, and then inhale oxygen, and the sky just lights up. I mean, the oxygen has that much of an impact on your eyesight. It really, increases it. So, yeah. Okay. So yeah,
it's sort of like the inhaler is almost like a steroid for your lungs.
Yeah.
So sometimes it's just like,
yeah, you go from blurry vision to all of a sudden clear vision.
it almost makes it like you can take in like double the kind of air.
Yeah. So that's a form of hypoxia. You're not getting enough blood, or not enough oxygen, which is reducing the oxygen in the blood. So in any case, that's one thing again. But after 15,000 feet, you have to have oxygen. Actually, you can provide oxygen up to 15,000 feet for your passengers. After 15,000 feet, they have to have oxygen as well. So you as the pilot, anytime over 30 minutes at 12,500, you have to have oxygen. Okay, required crew, that is. All right. And there's several different types. Again, you can read about this. There's nothing unusual there. It's just the FAA just refers to it basically as hypoxia. Hyperventilation, that's another thing that can happen. You start breathing rapidly. That's where you get too much oxygen in your blood. And what happens then is you can, that's on 17-4. When you hyperventilate, you're bringing in lots of oxygen. It's too much. Your body can't handle it, and it essentially, incapacitates the person. You can literally pass out if you hyperventilate. So the simple way to deal with hyperventilation is to talk or sing. I know it sounds weird, but when you talk out loud like this, you can't hyperventilate. If I'm hyperventilating, I can't talk. When I can do one or the other. I can either hyperventilate, breathe really fast, or I can talk, but I can't do both at the same time. It would be really tough. So if you talk to somebody or just talk to yourself, that'll help prevent you from getting this hyperventilation. The other thing you can do is just to breathe into a cardboard bag. Just grab a bag and just breathe into it really slowly. You'll see it expand or whatever and contract as you breathe in it. So that'll help. So, and again, there are things in there like with hyperventilation. Let's see, let's see what are the symptoms there. Yeah, common symptoms. They've got that. You should know the common symptoms of hyperventilation. Visual impairment, unconsciousness is one possibility. A lightheaded or dizzy sensation, tingling sensations, hot or cold sensations, and muscle spasms. If you feel any of those things, you're probably hyperventilating. That's the thing about hyperventilation. You don't always realize that you're hyperventilating. So again, the simple way to deal with it is just to start talking out loud. Talk to your passenger, talk to somebody else. To prevent that. So symptoms of hypoxia, blue fingernails and lips, headache, decreased response to stimulus, impaired judgment, euphoria, which is a feeling of really happiness. Everything's going great. That's why hypoxia is so dangerous. A lot of people have euphoria when they get hypoxic. Visual impairment, drowsiness, lightheadedness, tingling fingers, and numbness. So they're very closely related. They have a lot of symptoms that kind of cross over between the two. I think they've got some questions on both hypoxia and hyperventilation. Basically, how do you deal with hypoxia? How do you deal with hyperventilation? So, okay. Corporeal solution, yeah, they talk about that. I don't think there's really anything else that we have to go through here. Let me just make sure. Oh, some night vision issues here. We should probably talk about this too. Stress and aviation. So, if you just lost your dog or a family member or something like that, is it a good idea to go flying? Probably not. Yeah, it's just you're dealing with with a complex. It's not like driving a car where you just hop in and drive around. You're flying an aircraft up in the air. You fly around other people, and something could happen. You could it would be bad. So with stress, we do. It's a proven fact. You do make poor decisions. You make mistakes and things like that. So it's probably best to choose not to fly if you're really stressed out. You can also be sleep deprived. That can also cause problems with your judgment and stuff like that. Again, these are all things that you as a pilot are going to have to deal with. You're going to have to make the determination, am I safe to fly? And there's actually an acronym. It's called I'm safe. Illness, it actually stands for illness, medication, let's see, stress, alcohol, fatigue, and emotion. So it's a very common memory monitor acronym that the pilots use to verify that they're safe to fly. So illness, am I sick? Do I have a cold? Do I got flu? Something like that. My flying abilities. Medication. Am I on any medication that the FAA does not allow me to fly with? That's one thing to think about. But maybe you're on a drug that says, any drug that says do not operate heavy equipment, right off the bat, it should be a telltale sign. If you're going to use that, you probably shouldn't fly. I'm safe as stress. Are you dealing with stress in your life? A for alcohol. If you had alcohol in the last 8 hours. F, fatigue. You feel fatigued and you got enough sleep. Those are things that are going to affect your flying there. And then emotion. Are you emotionally stable to fly? And that can be kind of a subjective call on your part. Some people say, I just lost my dog and I can handle it. But they still make mistakes or something like that. So. Okay. The rest of it, guys, I think you guys can kind of read through. These are things that are not like may have some questions on these things, but it's nothing that's really earth shattering. Does anybody have any questions on what we've covered so far? So the next step is for you guys, definitely take those quizzes that are on the site, on the science site. Do the sporties things. When you guys are getting closer to getting ready to take a get a hold of me, or we can do it sooner if you want. But send me an email and I'll go ahead and get you guys signed up so you get your student pilot certificate then and get rolling with that. So I'll be around all summer, obviously. So if you guys want to fly the simulators, let me know. I can get you guys lined up with it. We'll see if we can get somebody to come in on the weekends or on the evenings. So if somebody wants to fly the simulators on the evening as well. All right. Thank you guys all very much for hanging in there all the way to the end. So I'll be getting or talking to all of you. I'm sure you'll be getting emails from me coming up in the next couple of weeks here about what's happening next. I got to take all you guys up flying. So you'll fly either the Twin or the Cessna 150. So we'll do a full flight lesson, log it, get you guys all with that. So any other questions? Good. All right, very good. Thanks a lot, guys. Appreciate it.
I gotta go to a concert.
Ah, that's why isn't it fun on a Saturday?
All right. Thank you, Joe.
Yeah, thank you. Then Trey, you take care, sir.
Yeah.